Hello and welcome to For the Love of Nature, a podcast where we tell you everything you need to know about nature and probably more than you wanted to know. I'm Laura.
And I'm Katy, and today we're going to be talking about gems and minerals. This is going to be one of our learning episodes. And so we're going to be talking about minerals and how they are essential for life, but gems, not so much at all. It's more just like a shiny object that humans really like to have.
Yeah,
and
that's something that we've always been really drawn to with shiny things, and we put value on them. We're just
way too much sometimes.
Speaking of, I actually just found out from a scientific article at work that like the whole crows loving shiny thing isn't necessarily true. It's kind of like a learned maybe behavior. Like they learn, like they know that people value it, so that.
Oh my gosh, that's terrifying. Though, if that's true.
I don't know. I'd have to redo more reading. They definitely, like...
Oh my gosh.
Adult crows don't hoard things. Baby crows do hoard things.
Which makes sense.
Typically, it doesn't have anything to do with being shiny. It's just things they find interesting.
Okay, so we have this.
So we're, like, bowerbirds?
Yeah.
Not gross.
Gosh. But at the same time... Okay, so we have this going on. We have that guy who is being interviewed on TV saying that we have... like that government has proof of aliens, like actual alien, and we have AI happening. There's just way too much. I think we're at the cusp of like insanity of just like
Crows
we're gonna go
figured out that humans have currency.
Yeah,
aliens.
Oh my god. It's just, this is when we all tip it. We're either gonna go full-blown, like, Terminator or, like, Apocalypse right now. Like, there's no in between I see.
Well, speaking of, you know how, like, we bring up, well, I don't, you bring up all the time, BT dubs, they said that there were aliens during, like, the pandemic. But I just saw, somebody just sent me a video of that on TikTok where somebody was like, you know, like, I know we were dealing with a lot of stuff, but, like, nobody cared.
Dude. I even have that on my dating profile that I was like, we gotta circle back around to this. Like, we need to revisit this. And we are. But, like, nobody's making...
We were too burned out to care.
Yeah, everybody was so, like, emotionally, mentally burned out that like, everybody was... Like, all of the world's governments was like, yep, aliens. And nobody cared.
Blinked an eye.
No, right? And so now I feel like people are bringing it up again. And because we were so numb to it then, people were just write these guys off as, you know, lunatics. Oh, they're just crazy, whatever. Or everyone's just like,
Yeah.
Like, tell me something worse here. Like, are they gonna take us out? No, I don't think so. We can deal with it. Yeah, don't care. We really got to circle back around to that, guys. And I don't know. I don't know what... I saw that interview with that dude, and then I don't think I haven't seen anything about him again since then. So.
Interesting.
Goodness.
Aliens.
Alrighty. So, other than, like, aliens maybe or maybe not attacking and invading Earth, I don't have any other nature news.
Nah. I think that's enough.
No. Yeah, that's enough. That's enough. We're all gonna die. Like, we're good. Alright, let's gems and minerals then, or I should say minerals and gems, because you have to kick this off. Because
I'm in the groundwork.
Yeah, because yours is all important and everything in life needs it, and mine not at all.
It's just like a matter of like this is almost it's not a taxonomy episode, but it is along the lines of like
it's a learning one.
I'm the broader category here.
Yeah.
And Katy is a subset. Like gems are minerals.
Yep. Just the shiny kind.
Yeah. So actually I learned a ton. I'm really interested kind of in geology, and I was like, ooh, as I'm reading a lot of this stuff. So we have been mining minerals. Katy, how long do you think that human beings have been mining for minerals?
Like actually mining, or just like digging,
I guess finding? Digging for them.
I mean, I would say like it's got to be not too long after. I mean, like humans, like not Neanderthals, but it's got to be like around humans times, like from the get-go.
42,000 years to be precise.
Okay.
Which is bananas!
Yeah, but I mean, it makes sense.
They found the earliest evidence of it in South Africa in a mine, and they were digging up red pigments, probably for painting and communication.
Oh, okay. I figured someone licked a rock.
And they were like, ooh, salty.
Ooh, yeah, right. That's what I figured. I was totally off. They're like art and everything red, and I'm like, someone licked a rock.
Some ADHD caveman.
Right. Yeah, right. Listen, ADHD, I would have survived so well back in the day.
That we figured out what salt was because we saw animals licking it. So I bet that we licked it then too.
I guarantee it. So I'm sure. No offense, but it had to
eaten eggs or like anything like that. Surely we watched another animal do it first.
But again, no offense to men, but I guarantee you it was a dude who first licked salt. Like they saw an animal and then they're like, let me go lick it too.
Maybe someone's thinking about this.
Yeah, had to have been a dude. Yeah. No woman would be like, an animal's licking that. No. No woman's gonna go do that. Had to have been a dude.
So minerals, they've been around since the very beginning because they are the basic geological building blocks of solid earth. So we've done an episode in the past called Rocks Rock where we kind of broke down like geology and rock types. This is even broader because rocks are just made up of minerals. They're like, if you think about a rock as like a cake recipe, the minerals are all the different ingredients that go into the rock. And then gems and metals are subsets of minerals.
Mm-hmm.
So like minerals and then subset gems, subset metals. And then there's like a couple of other rando ones. So what are they besides building blocks? The technical definition has to have a couple of things that are important about it. They are inorganic solids that have a characteristic chemical composition and a specific crystal structure. Okay? So first of all, they have to be a solid substance. Single throughout. It doesn't have to be pure, but it's got to be pretty much the same thing throughout. So because of this definition, technically, ice is a mineral. Not
I've heard this. Yeah, I've heard this before.
But solid ice is technically a mineral. It's made from molecules or elements that are arranged in chains, sheets, or three-dimensional structures. So that's what we mean by like a crystal structure. They're arranged in a certain way. So crystals are just an ordered internal arrangement, not necessarily flat faces. Like, I'm not necessarily talking about the crystals that you might be thinking of, which are like beautiful, pointy.
Yeah.
Like,
yeah.
That's just not like a wizard's crystal. But just something that has some kind of structure inside.
We're really showing our true sides in this episode.
Yeah, I'm just going to bring up fantasy. You're going to bring up aliens.
All day, every day.
Morphologically, which means externally, so like their external shape, crystals can actually be grouped into 32 classes, which is overwhelming. And that represent the 32 possible symmetry elements and their combinations. Okay? So this all has to do with if you study like mineralogy. That's a hard word to say. Mineralogy.
How can I say that word and I can't say?
Not the Latin.
Yeah, nothing. I can't say anything half the time.
Mineralogy. And then like specifically like crystalline structures and things. So 32 classes and then lumped into 6 systems, such as hexagonal, tetragonal, yada yada yada.
Oh yeah.
So if you looking at a chart of crystals, they would be like split into these 6 giant categories and 32 smaller ones. But of course, that's not the only way to kind of figure out minerals. It's just
of course it's not.
Right, it can't be simple.
No.
So that's
science is never simple.
That's just the external shape. That's what it looks like to the naked eye, and it reflects the internal crystal structure. So the crystal structure of the elements inside is giving rise to what it looks like on the outside. To be complicated, some minerals have more than one form, so they're called polymorphic. And an example of this is carbon, which can be both graphite and diamonds, depending on temperature and pressure. And so the reason why they're different is because they have different crystal structures. So
gotcha.
Same thing, same mineral, but different forms depending on some factors. They're not all like that, but some. And minerals can be expressed as a chemical formula. So boy, if you think back to your chemistry days.
I don't want to.
I know.
Yeah, right.
If you think back to your chemistry days, things can be represented by chemical formulas based on what's inside of it. So it could just be, some minerals are just elements. Sulfur is a mineral and just a plain old element. It's in its purest form, just sulfur. S for sulfur. Other ones, though, are compounds, like SiO2, which is like for silicone and oxygen. That's quartz. So, but because, not all minerals are pure, most have a range of chemical compositions when, like, ions move around, and getting into way too complicated stuff to talk about on here. If you're interested, there it is.
Google it.
Google it. There are more than 5,000 types of minerals on Earth. Ugh. And typically they're very small because they form within a confined area, like a teeny tiny space within a rock. And they form from natural processes. That's the rule. To consider technically a mineral. Although we can now make minerals, like we do hand make them. They're natural. But, my original definition, you might have heard me say inorganic solids. Typically, they're inorganic. But we also kind of consider, like, pearls a mineral.
Okay.
But they are made from an organic substance.
Yeah.
That's secreted by those oysters. Okay, so that's what a mineral is. What makes them form in the first place? It depends on the geologic conditions. Like, what kind of rock is around? What is the chemical composition of the magma? What kind of pressure is going on? How hot is it? And is there a lot of fluid around? Which is a gross thing to say, but that's what minerals need.
Minerals just need all those fluids.
Yeah. And this is a direct throwback to our Rocks Rock episode, because we talked about that there are 3 different types of rock. Okay. Mm-hmm. There are also the main categories of mineral formation are very similar to those. There's igneous, which is ones that crystallize from a lava melt. Mm-hmm. Sedimentary. These are minerals that result from the sedimentation of other rocks. So as the rocks break down, they're forming. Metamorphic, which is minerals that form at the expense of older ones when temperatures and pressures change. And then the last one that is not a type of rock is hydrothermal. So they are chemically precipitated, meaning that they, like, how do we explain this to the layperson?
I don't remember what we did, because I remember we broke it down.
Like precipitation. Yeah. Think about, like, rain, that's precipitation. So, like, the minerals come out of these hydrothermal vents and other hot solutions within the earth. So, minerals do have, in that definition, we said that they had certain chemical and physical properties. Most crystals don't appear alone. Like, it's super rare to just see, like, this perfect crystal in one single shard. Usually they form in, like, a clump called aggregates. Mm-hmm. And then you can then kind of lump different crystals based on a descriptive term. Like, are they granular aggregates? Are they globular aggregates? Are they, like, that kind of stuff. Also, geology, and maybe you'll go into this with gems, I don't know. But to identify certain types of rocks, minerals, and gems, there are physical properties you're testing for. You're looking at the hardness, like how resistant is it to scratching? Its cleavage.
Your face.
No, but that's how cleanly it splits and in what direction. Its luster, which is how it appears in reflected light. Its color. Its tenacity, which is such a funny word.
Yeah, that's such a funny word.
Non-living. That just means how flexible or malleable.
The tenacity that it has.
The tenacity of that mineral. Its specific gravity, magnetism, fluorescence, like does it emit light under UV? How soluble is it in hydrochloric acid?
Jeez.
Radioactivity, fusibility, electrical and thermal conductivity. I feel like I'm doing a rap.
Can you please turn it into a rap?
Radioactivity, fusibility, and all of these physical properties are based on the forces that are holding the atoms together within that crystal. So, like, all minerals have different things about this. Some are harder than others. Some have different cleavages, which is...
I just want to hear you rap.
Which is...
I'm just stuck on that now.
Okay, just a few more things. So, classifications of minerals. Okay, we could classify them based on crystal structure. Cool. We could classify them based on their, like, aggregate stuff and their other physical properties. But since the 1800s, they have been classified based on their chemical composition, which is not a complete picture. And every science, like, all the mineralogists acknowledge this, because internal structure should be examined, like the crystal stuff, and its physical properties, not just the chemical ones. But the broadest definitions of minerals. Like, you can break down all minerals into the following groups. Native elements, which means they occur in nature in their purest form, which is carbon and sulfur, and then certain metals, semi-metals, and non-metals. Sulfides, sulfosalts, oxides/hydroxides, halides, carbonates, nitrates, borates, sulfates, phosphates, and silicates. Now, silicates are the most important of the mineral classes, although I feel like that's pretty subjective, but that's what the article said, so I'm going to go with it.
I'm going to just go with it.
Because 25% of all known minerals are silicates. So, like, of all those different categories, this is 25%. 40% of them are the most common ones on Earth. And they make up 90% of Earth's crust. So, like, they're the minerals we're mostly going to encounter are the silicates. Which brings me to my one mineral highlight before we can move on and talk about gems.
My one mineral highlight.
I mean, there's a lot of cool minerals out there.
There is
salt, because most people don't think about salt being a mineral. But quartz has always been close and dear to my heart. So, quartz. It is the most abundant mineral on Earth. It's found in all types of rock, created at all temperatures. It's like generalist rock, and I always admire the generalists. I consider myself a generalist.
I was gonna say that needs to go on a t-shirt, but I admire
myself a generalist.
No, that you admire the generalist. Oh. I truly admire the generalist.
As I mentioned earlier, it's made from oxygen and silicon, which are super common elements in Earth's crust. It's resistant to chemical and physical weathering, so that means that most mountains, beaches, and deserts are made of quartz. Like, some beaches are literally just quartz sand.
I think it's like that's the one
that's left.
I can't remember if that's the one, if that's what it was. I have to look it up, but whenever we were in Destin, we were walking on the beach and it squeaked.
Ooh.
Like, it squeaks when you walk.
Maybe.
Continue, and I'll look it up what it was. There was something unique about it.
It's heat resistant. It has certain electrical properties. And it can be pretty much any color. Like, a lot of times when you're looking around, you see, like, white lumps of rock. That's quartz. But it can also be, like, pink and gray and so many different colors, all based on other things found inside of it. And it's super useful. We use quartz for all sorts of things.
Okay, so it is quartz sand. Okay. That it's the shape of it that makes it... No, like, legit makes it squeak.
Like snow.
Yeah.
You know how, like, snow squeaks when you walk on it?
Yep.
So we use quartz for so much because it's the most abundant thing, so why not? So we use it in glass making. So glass sand, like Katie was just talking about, that's like that kind of sand, the kind of sand that's 99% quartz. That's the kind of sand that they're going to want to turn into glass.
That squeaky sand.
That squeaky sand.
Gotta find me some of that squeaky sand.
And make some glass. That'd be so cool. They typically turn it into containers, fiberglass, and specialty glasses, like telescopes, microscopes, and other scientific instruments, like lasers was one I mentioned.
So like a fine glass.
Yeah.
Like it's more like the fine glasses.
Quality.
Okay.
Yeah. It's also used as foundry sand, which is like, you know, they have to make, when you're pouring metal, when you're casting metal, you gotta pour it into sand, which is the mold, because it doesn't melt. This is used for that. Quartz is also a gemstone, which Katie will be talking about in a second.
Yep.
It's used in fracking. So, like, they shoot quartz down into the earth, and it's so strong that it holds the cracks open so that the natural gases can get through. It's used in electronics, scouring cleansers, grinders and sanders, fillers and paint putty and rubber, filter media, roofing granules, recreational sand, like in volleyball courts and kids' play sands and all sorts of stuff. That's mostly quartz. And finally, something I had not heard of, but which is all through our lives, called crystal oscillators. So one of the cool things about quartz is it vibrates at very precise frequencies. And these crystal oscillators were developed in the 1920s and then blew up during World War II because they really needed them, because they could be turned into radio transmitters, TV transmitters, and even timepieces. And we're still using them today. Today, they're used in watches, computers, radios, GPS, cell phones, all sorts of anything that needs to be precise at keeping time or precise radio waves.
Yeah. Quartz.
And now we can synthetically create, and we synthetically create quartz for a lot of the electronics and like the glass instruments that we need rather than mining it, but we can. And that's it for minerals. I mean, I have why are minerals important, but I feel like we can circle back to that after gems.
Yeah, because gems aren't important.
Some other people out there are like, what?
Yeah.
Diamonds are not my best friend?
Yeah, right? No, they're really not. So, while, like Laura said earlier, you know, minerals, it's the big overarching, where gems is like a subset of it. That is not, even though it's captivated humans for thousands of years.
There's been like horrible things done.
Right? And for gemstones, and that have no value other than the value that we put on it because it's pretty and shiny. Bananas. Yeah, that's it. Like everything Laura talked about, because it's not like doesn't have the shine to it. You know, it's essential for life, but it's not a high price. But then gems, which serves no purpose, but it's pretty, so we're gonna just put a high price on it. So craziness, but. So their allure, though, for gems lies in the colors, the stunning clarity, and just the brilliance, and I'll get into some of the other little features of it. So, the formation and classification of gems, similar to allures, it comes from, again, minerals, and processes, and it can take thousands or millions of years. This process includes the crystallization of minerals under specific conditions of pressure, temperature, and chemical composition. So again, everything that Laura talked about, some of them are going to give you quartz, some of those processes are going to give you these gemstones.
And like it's still just a mineral.
It's still just a mineral.
Some things to it.
Yes. And it does have some natural qualities that other minerals don't have, but the diverse array of gems can be classified into distinct families or types based on their unique chemical compositions and distinctive crystal structures, further enhancing our understanding of their origin and characteristics. So, some of those properties that we're talking about, it encompasses an array of a variety of properties and characteristics that contribute to what we see as just gimme, and we can't say no to it.
When I was reading mine, like, it seemed like what I was finding was, like, technically, like, the difference between a plain old mineral and a gemstone was that gemstones have facets that are cut.
Yes.
But I'm sure there are other things.
Yeah, there are a few. So color, so a lot of minerals that you would talk about, it really, that is one of the ones that prominently stands out between minerals and gemstones. So if you think of most minerals, for the most part, they're going to be like your earth tones and things like that. They might be, I don't know, like a brighter orange, but it's not going to be like a gemstone. Think ruby and things like that. So it's going to like really stand out. So yes, it is a mineral, but like that color is just, think of like an emerald. Like, can you imagine the first person that found an emerald? Like, even if it's like uncut, not shaved, all that stuff, you're just like, what is this? Like, yeah, it stands out so much compared to everything else that would be around it. And so it's because that variety of palette of the hues, a variety of different colors, that really makes it stand out compared to other minerals. The other thing is the clarity and transparency, which are critical aspects of the gems. And that's, depending on, everybody knows, what is it, like the 3 or 4 C's. I don't really go into it, but it's like clarity, cut, whatever, that give gemstones their value.
Okay.
But it's the clarity and the transparency. Obviously, some gemstones have more clarity than others, but overall,
like an opal, I mean, like,
I have an opal somewhere that has a peregrine falcon carved into it that I got in Australia. Yeah, really like it. The optical effects, a lot of gemstones have optical effects that most common minerals don't necessarily have, such as iridescence, asterism, which I had to look that up, but that is whenever there's like that star light pattern that you see on some of the gems. The color, some of them have color change, and
that's so cool.
Yeah. And just a variety of other things like that. So again, it's a shiny object that makes it stand out. The durability and hardness measured on the Mohs scale. I don't know if you talked.
I just mentioned in past. I didn't say Mohs scale, but hardness was definitely like one of the physical properties of all minerals.
Yep. And so that is the same thing, applies to gemstones too, and has to. I don't want to say it has to do with their value nowadays, but it does still play into it. So furthermore, properties like luster and specific gravity provide valuable insights into the visual appeal and density of all gemstones, further enhancing their allure and desirability to people for thousands upon thousands of years.
Yeah.
So let's talk about some of the major gemstones and their features.
Yes.
So while there are thousands of minerals, there are only some sources I found that said 100 gemstones. Some were saying like 130.
Okay.
So somewhere around there. Out of the thousands,
I'm sure it depends on what some people consider, because
exactly,
it said that quartz can be considered a gemstone.
Yeah, like, if it's polished up, shiny, if it has a certain certain characteristics, yes, right. It absolutely could be. So, but of those 100, there are like 16-ish, which are seen as the key or the major groups.
Okay.
So these are Beryl, Beryl, B-E-R-Y-L.
That's my grandma's name.
Oh, really?
Yeah.
I
they just said Beryl, but I don't know if that's really the way it's said.
No idea. So there's Trisoburo, corundum, the diamonds, feldspar, garnet, jade, lazurite, avaline, opal, quartz, so this included it, spinel, topaz, tourmaline, turquoise, and zircon. Okay. So I'll just go into a few.
Because I definitely remember, like, reading earlier, like, I didn't, you think, like, we didn't just hear the words ruby and emerald, because they are a type of one of those things, which is so wild. I feel like nobody knows that.
No. So I'm just going to go through some of the other ones. Some of these ones I didn't mention real quick, but just the highlight, I think, even though those are the 16 most popular ones, I think the ones that people recognize, obviously diamonds.
Definitely.
Which
diamonds are diamonds, but like lots of colors, right?
Yeah, they can come in a variety of colors. It's that variety of colors, but it's the diamond's worth comes in when it's the clarity, the cut is, man, but there's still some cut as far as like the natural crystallization of how everything's lined up and whatnot. So their remarkable optical properties, obviously, people have just been drawn to them, and it's always been seen as a status of, elegance and wealth. However, as many people know, diamonds are also shrouded in tragedy and greed. Like, some horrible, horrible things have happened.
I've always wondered why we chose diamonds rather than something else. Is it because we value things that are clear?
I don't know.
Like, I feel like there's got to be some psychology behind this.
I don't know, because honestly, like, they're just plain. Like, to me,
I've never thought that they were the most beautiful.
No,
I
definitely
like the colors.
Not. Me too.
But I guess if you thought, like, they looked like starlight, like, I don't know. There's gotta be some reason.
Well, another one, though, that this one I can definitely see, rubies.
Yeah.
Because of their deep red color, command admiration and desire. Again, their rarity among gemstones, combined with their remarkable durability and mesmerizing beauty, makes them highly coveted and cherished by collectors and connoisseurs alike.
What rubies group are
they in? Well, because there's the 16 main ones, but there's still 100 ones, so they're their own separate thing.
Okay, so rubies.
I don't remember. I think so.
The emeralds are not. That's what I was thinking.
Yeah, I don't remember. Another group, though, and this one was not one of the 16 that I mentioned, but I'm going to go for it because this is my birthstone gemstone, and that's sapphires.
Yes!
I love it. I know. I love sapphires.
But sapphires are in some group, right?
Dude, you're asking too many complicated questions.
This is easy. This is your category.
Well, because there's 100.
Yeah,
there's 100 different ones.
What?
It's a corundum. That corundum one.
Okay.
Yeah. So
that's for sapphire?
Yeah.
And so are rubies.
Rubies are too? Okay.
Yeah.
So those are both the corundum ones. So sapphire are the deep, deep blue ones. I mean, they come in a variety of colors, again, like a lot of gemstones. But most people, when you think sapphire, they think of that dark blue, which is gorgeous.
Yeah. That's what I wanted, not a diamond. I wanted the
sapphires are so good. Emeralds are another one. Again, lush green color. Another one that I can totally see why people would want this. Diamonds, don't know. Emeralds,
they're in the Beryl group.
Emeralds are in Beryl? Okay.
Yeah. May's birthstone. That's my brother's. I was always jealous because I don't like garnets, and that's what mine is.
Yeah, mine is sapphire, and I was so happy.
More boring version of a ruby.
It is. It really is. I'm so sorry. So, in addition to those main gemstones, like I said, there are a plethora of other gemstones that possess their own unique qualities and appeal. Amethyst, for instance.
Which is just a type of quartz, I think.
Yes, I believe so.
Which is cool.
Topaz. I mean, there's so many opals. Again, there's so many different ones that are just fascinating.
Those, like, fire opals from, like, New Zealand and Australia are probably the most beautiful thing on planet Earth.
Oh, hands down.
It's like a rainbow or a peacock exploded in a rock.
It's a peacock. It's like a peacock exploded in a rock.
A peacock exploded!
Oh, goodness. So we talked a little bit. I'm going to go a little bit more into the history. So throughout history, gems have obviously held cultural and symbolic significance in various ancient civilizations and mythologies. And honestly, when I started, I couldn't go into all of this too much.
This should be an episode on its own.
Yes.
It's just gem culture because I think it's fast.
It is insane. That's why I didn't go into it too much because I was like, oh my goodness, this would be a cool episode because it was really neat. But overall, though, gemstones have been associated with power, wealth, and social status throughout different periods and cultures. And it definitely was like trends. Like you could see trends. Like for a while, it was like, oh, sapphires, or like in this culture, this area, sapphires was the thing.
Plus, and then like because they are very regional, because it depends on the type of rock that there is.
But then as people traveled, then it was like, oh my goodness, we need to have need to have that. So then it would, kind of trend and keep going and move with people. So there's also gems. They hold spiritual and metaphysical importance to many religions and spiritual practices. Again, that could be a whole other episode in itself. A lot of people believe they're there to possess healing properties, enhance spiritual energies, and aid in meditation and self-discovery. Gems have been a constant source of inspiration for artistic expressions especially. And this was another interesting one too that I was just like, so they have been depicted in ancient literature, celebrated in paintings, all kinds of stuff that people mimic gemstones and sculptures. So anytime I was looking through like some of these sculptures that people have done like a long time ago, and you know what? It would almost be like a kid today drawing a picture, and then they like always would draw like a mom with a necklace on.
Okay.
It was the same thing. It was like they included a lot of these gemstones
accessories.
Yes, they accessorize, their sculptures and stuff. So it's just really, really interesting.
That is so cool. The sociology behind any nature stuff is like it's so fascinating to me.
Oh yeah, yeah. So because of that, back in the day, a lot of those gems, they weren't polished and cut and everything like that as much as they are today. They were still chiseled and chipped away, shined up as much as possible. And so gemstones today, though, undergo an insane amount of cutting and polishing processes, utilizing trained and specialized technique and tools.
And I'm sure they're like grown at this point too, right? Like
they can't. Yeah, like mimic. Yeah, like the fake ones. But over time, like I said, like it used to just be a significant sign of importance and everything. And then once man started, like today, really started getting a hold of it and started shifting it and cutting it to how we want it to be. It's almost, I don't want to say it's gotten, like, faker, because we have started, like, growing things, but at the same time, it's like, it's almost lost some of its natural beauty, if that makes sense. Because we've cut, we've polished, we've done so much, and we've put it in through treatments to enhance the color and clarity to make it, like, so that you could really see through it. So it's almost like, again, like so many things, humans step in the way because we're like, oh, we got to make this better. But we throw it so far on the other end of the spectrum
that it's not even really what it ever was.
Yeah, it's not really what it was.
Interesting.
Because still, if you look at like natural, like uncut, uncleaned, like rubies, like it's still really pretty. It's just if you look at what it comes out of the earth as versus now, it's like it looks two totally different things because
the clarity isn't really there, which is the crazy fascinating part where you're like looking into the universe.
Yeah, it is nuts. So of course, anytime we talk about gemstones, obviously Laura and I already touched on it, the ethical considerations are always going to be discussed and talked about. It is very important, and I mean, I would like to say nowadays people are aware and conscious of like, oh hey, is this good or not? Is this done under best practices?
Yeah, like ethical diamonds, yeah.
But it's so easy to just fudge all that.
Oh, I'm sure.
You know what I mean? And so that's what's sad about all of this is like, especially diamonds, like sapphires, things like that, opals. I mean, because again, whenever I was in Australia, the opal I got with a peregrine falcon on it, there was an opal mine nearby, and then we went to a jewelry store, and so it was really cool when they made that peregrine falcon one for me. But like nobody there it wasn't like
forced
sad,
yeah,
forced labor for opals, like it is for diamonds. And so obviously over time, the gemstones, they've been influenced by, again, the color, clarity, the carat weight, which I didn't really talk about, but the rarity, all of that goes into that greed and that hunger for just the best, the better, the biggest diamond, the, clearest one, all kinds of stuff. And over time, as we've added like grading and clarification or certification systems that add like, I don't want to say fake value, because obviously if you want like a clear gem, that's good. But at the same time, it's like we've put all that value onto this thing. Like we've designed certifications and grading to say, hey, this gemstone is better than this one, is better than this one. So we're just like forcing additional like, I don't know, additional value onto something. So we're the ones that are saying it's valuable. When, yes, diamonds serve a purpose in a lot of trying to think of something.
Manufacturing, even.
Yeah, there is like
paper. There's like diamond sandpaper.
Yeah, like diamond tips. So there are like purposes for it, but you're not gonna find like diamond tip sandpaper or the drill bits and stuff that are gonna be, perfectly clear diamonds. It's just not that. So again, we have it in everyday stuff.
Can you imagine how many dud diamonds there are that they have to go through to find the good ones?
Oh my gosh. Yeah, and so that's what I'm saying. Like, we're the ones who have taken that and kind of run with it, and we're the ones who've added that, like, extra layer of insanity onto it, of just, this is what makes it valuable, this is what makes it good. And so, why are people fighting over all this whenever this is literally something that we've put onto it? Like, it doesn't really serve a purpose.
All the other, like, the precious metals, which are also considered minerals, but the precious metals, it's just...
But a lot of the metals, though, you can still use for a variety of things. Most of these gemstones are just gemstones. Like, they're just shiny objects. Yeah. That's all. And I mean, I love them, but at the same time, it's just a shiny object that we put a ton of value into.
Yeah.
And so that's where a lot of that conflict and all kinds of just global enterprise and just the trading and smuggling and all the craziness that goes on. So anyway, so some of the contemporary uses of gems, I mean, Laura and I already hit on some of these, besides like the, industries of necklaces, bracelets, earrings, rings, all that kind of stuff. Certain gemstones, like we talked about, such as diamonds, have industrial applications due to their exceptional hardness. So there are, again, a few of these gemstones that do serve a purpose. Very, very few. But many people believe in that metaphysical healing property. So again, once all of that stuff has started trending and coming back, like the stones and the crystals, a lot of the, I don't want to say least popular ones, but like the amethyst, those started making a comeback. Yeah. So their values have started to go up and things like that. But gemstones, again, it's always been trending with, because it is just a shiny object, it's been humans assigning value to it. It's not like minerals where some of those minerals we might need more than others. So you would think that the ones that we need more have more value to it, where than other ones less valuable. Gemstones were the ones that are assigning the value to all of it. Yeah. Like, there's really not a whole lot of sensibility behind this other than what we're doing to it.
Other than what we think's pretty.
Yeah, just what we think's pretty.
So I just wanted to bring it back at the end of, of course we just talked about why gemstones are important for cultural reasons, wealth, the economy, all kinds of things. But in general, why do minerals matter? And I'm here to tell you that minerals matter a lot, because we'd be literally dead without them.
Right.
So, and we wouldn't have like earth to walk on. But
besides earth to walk on.
But just a couple of like highlights. Humans need certain minerals to remain healthy and function. Like, people used to not think that mineral deficiencies were a big deal, but mineral deficiencies can kill you.
Yeah, it's a huge deal, yeah.
So you need to have salt, and you need to have some other things, like zinc and like things like that.
Take your vitamins, folks.
Take them. They have been and continue to be essential for technological advancement. And when I first read that, I was like, what does that even mean? But duh. Okay, like, from the beginning, technology is also stuff like cave paintings used as communication devices. Fire uses minerals such as flint and,
oh, yeah, I didn't even think about that.
Yeah, and then, today, like, primitive man making tools out of certain minerals. Now we use them in cell phones, like, all through time that we have relied on minerals to carry us through with technology. They're used in nearly every aspect of our daily lives. They're a crucial part of our culture. We're trying to find ways that we can use minerals to combat climate change by using them as carbon sinks. And
interesting.
Like carbon sequestering.
Yeah.
And just my final thought, just to leave you with this, of how essential they are. The USGS estimates that the annual, mind you, mineral requirement to maintain the standard of living in the United States is 18 tons, which is 40,630 pounds per person per year of minerals. Because that is things like stones, sand, gravel, cement, clay, salt, iron, phosphate, soda ash, aluminum, copper, lead, zinc, manganese, other metals, and other non-metals. So, like, we are consuming, one person per year in the United States is consuming such vast amount of minerals. And they were even saying, like, it's not just, like, sustainability at this point, too, because even, like, sustainable options, like sustainable cars. Yeah. Yes, we're not using gas, but we're using vast amounts of other things for something. Like lithium-ion batteries is using, so, like, we're still
how sustainable,
consuming
how sustainable
minerals.
Is it? Yeah.
So we definitely have to think about our mineral consumption.
Yeah, I don't think anybody is talking about that right now.
Absolutely not. That's the last of anyone's priorities. Right. But
we've got aliens out there.
We're in trouble.
We're not even talking about aliens. Why would we be talking about minerals and our consumption?
Have you thought about your mineral consumption lately? Right. Like, instead of car insurance, I'm just calling people.
The car warranty. That would be such a funny prank, though.
It would be. Have you thought about your mineral consumption lately? What?
Yeah.
Well, I'm here to tell you that.
That would be an amazing call. Amazing call. All right, guys. Well, that was a quick overview on minerals and gems. Go ahead and follow us and reach out to us on Twitter or visit us on Patreon. Yeah. I normally say something else, but yeah, just reach out to us and hopefully share your ideas if you guys have episode ideas. I like if my mind just stopped working.
No, it's all right. It's late and we're about to start a new week, so my mind's already like,
right.
But yes, so everyone, we hope that you've learned a little bit. And hopefully you care just a little bit more. And we hope that we'll see you next week. Bye, everybody.
Bye.